Good evening. So I'm so thankful to all of you. I get so many mails, and I'm really happy that you guys are enjoying the studies. So thank you and wish you all the best. Okay, so let's start with our next topic. This is week 2, day 2. Welcome. And say this week as we are discussing the endocrine system, right? So we'll be going the next step. Now, from today, things would be very specific, right? It would be really very specific. Yesterday, what we learned about was the in general. Right? Today's topic, coming to that, right? That's the introduction. You know that. Okay. So for today's topic, so we'll be in fact tracing the endocrine system from the top till the last organ, right? So today we'll be talking about hypothalamus in reasonable detail, and then we'll continue with the pituitary, right? In pituitary, though we are learning physiology, but we'll study the histology in bit more detail. Reason behind that there are some special type of cells, and when we learn those special type of cells, it will make our rest of the journey much easier. And then we'll be going for the hormones, right? And obviously, it would be like anterior and the posterior pituitary hormones. My guess is that, say, two important hormones like, say, ACTH and the growth hormone, once we'll discuss this much, I think batteries would be exhausted by that time, right? Because all these topics, they are pretty big. So my guess is that this is the posterior pituitary, in which there are another two important hormones like, say, ADH and that oxytocin, right? And even that prolactin. So they are also equally important. No worries at all. That portion we can take. So tomorrow we'll continue from that point, right? Let's see how much we progress, and then accordingly we'll see. Okay. All right. So let's start with our hypothalamus. Now, this pattern, the way I'm writing, this is what is called as the brain mapping, right? You must have noticed that I usually avoid writing long, full sentences, right? I usually avoid, unless and until it is very much necessary, so then I write. Otherwise, it is all in the form of keywords. Say, as there were few emails about this. Well, there are few videos available on YouTube where I have explained this concept in more detail, right? A question was asked that why you are not teaching on PowerPoint. Well, nothing wrong about it, but actually it happens like, say, if it is PowerPoint, so then the sentences are there. What's the point in just reading those things, right? Over here, what we are trying to do is we are trying to write only the keywords. Now, actually, it would happen that when you'll start revising and you will just read those keywords, the rest of the sentences, they will automatically be created in your brain, right? So that's the reason. And in that film, I mentioned, I don't know whether you are following it or not, but this phase, this is like your sleeping time. These are your sleep hours. So 10 minutes, 5 to 10 minutes before you go to sleep, and 5 to 10 minutes as you wake up. If you just scroll through this particular PDF, right? Any of the PDF which you really want to revise, just spend 5 minutes on that before you go to sleep, then peacefully go to sleep. Next morning when you wake up, again revise. You'll find suddenly that that topic becomes so easy. As one of the question was that that's when he said that I am finding, say, physiology very difficult. I said, no, but no worries, right? This is especially for her. In fact, it is for everyone, that if you follow this pattern, suddenly you'll find that subject is so interesting, right? And whatever I'm telling you, it is only that thing which I have implemented on myself, right? Since notes, I think I have already given the links, Ankur. The links are there. Even in case if you have not received the link, just send a mail to me, right? On that till you are MBBS, I'll send the link again. Don't worry, right? I'll do that. Okay. So this is the topic which we are planning to take today, right? So this is like hypothalamus and pituitary. So let's start with our today's topic. So see, in hypothalamus is everything for life. As such, we say that our brain is like 1400 to 1600 grams, right? That is about 1.4 to 1.6 kilogram. This much brain is actually highly influenced by this 4 grams of hypothalamus. Yeah, it is just 4 grams. It's that small, right? But right from the hunger to thirst to body temperature to mood swings, right? Happy, sad, crying, all those things, they are like handled by hypothalamus. Hypothalamus itself is a marathon topic. We are focusing ourselves onto only the endocrine part, but as such, when we'll be studying psychiatry, at that point you'll see that hypothalamus is associated with so many things, so many, right? Even many of the eating disorder, that is like say bulimia nervosa, people keep on such eating, or anorexia nervosa when they don't eat, right? All these factors, right, they will be coming into picture. So that's why hypothalamus is so vital, right? Right from the hunger to thirst, body temperature, right? And all so much. We'll see. Now for the proper orientation, that where exactly the hypothalamus is. Not only that, what is above, what is below, behind this, that. Screen is not clear. Screen should be clear. When you say not clear means what's happening? I think it should be pretty okay because bandwidth over here is, so there is no problem at all. Okay. So what I was telling was that for the proper orientation, right? Because we are learning hypothalamus. So for proper orientation of hypothalamus, I'll just pull one figure and then we'll try to say figure out every part in it. So that will make things bit easier. Oh, okay. Blurry, it's clear. Say if it is clear for almost everyone and just for few of them if it is not clear, yes, please try to refresh or improve, take the quality. Yeah, that's what I'm telling. If it is not clear for 1 or 2%, then there must be some network issues on your side, because over here it is over 200 Mbps. So there should not be, and it is right now also I'm watching it is 189 Mbps. So shouldn't be a problem. Anyway, right? Worst case scenario, in case if there is any problem, right? In case if there is any problem, because it gets recorded onto the YouTube, right? So anytime you can just go back, and if there is any network issue, it gets cleared within few minutes on your side, so you'll be able to see it, right? Should not be much of the problem. Okay, so let's start with, and this is the figure, and let me freeze this figure so that you get it in your notes also. All right, done. So here is the hypothalamus. This dark part, this one, right? This one is hypothalamus. Right? So that is hypothalamus. Now it is said hypo, right? Hypo means it is under the thalamus. So thalamus has to be just above it, you know? Yeah, exactly the same thing. This portion, what you are watching over here, this one, right? That one. This is thalamus. So that is thalamus, right? And if you figure out, you can see a small portion, right? Like this dotted thing, this like this. What I'm talking about is this, right? That is choroid plexus, right? Choroid plexus, which will play important role in the secretion of CSF, right? Choroid plexus. Just above that curve, right? It is what is called as the fornix. This one, right? So that is fornix. Now, as this is a very good question, definitely I'll be asking this thing in exam. Okay. Then we have, right, all the way, you can watch this, right, this which I'm highlighting. This is connecting two parts of the to half of the brain, that is corpus callosum, right? So these are the structures which we are getting, right, which we are getting above, right, which we are getting above the hypothalamus. Now when we see below, this is why it is so important, because just behind it, just behind, that is over here, let's change the color, right? Just behind it, it is this portion, right? It is midbrain, right? It is midbrain. And then this is what is the pituitary gland, right? But pituitary gland's posterior part, right? This is the posterior part. That posterior part is as good as the continuation of hypothalamus. True? And that's the reason that is called as the infundibulum or pituitary stalk. Right? It is pituitary stalk. Oh, you can't see it. Just a minute. Right? So that is pituitary stalk. That is mammillary body. Mammillary body. Right? And finally, that is optic chiasma. No, Sandeep, I think if everyone can see it clearly, there is no problem on this side, because I can see the bandwidth. It is 100 and right now it is 192 Mbps. So definitely no problem from on this side. Okay, so optic chiasma, mammillary body, midbrain, these are the areas which you should know about the hypothalamus, right? Now let's start with, yeah, pituitary stalk. It is this. That's the pituitary stalk. Now we start with, say, even if the screen is blurred, right? Yeah, because you see, in many of the case, most of you are telling, yes, it is clear, and it has to be. It has to be. Mammillary body, as I marked it, right? It is just this portion, right? I am highlighting it. It is this portion, this portion. Okay. So please manage with the quality, and now, because now we'll be going bit fast, and as there is lots of ground to clear, right? Okay, so let's start with now the parts of the hypothalamus in which we are interested, and this is where we'll be drawing it something like this, as if we are watching it in a coronal plane or coronal section, right? The section which is passing through the hypothalamus. Now, in this case, we are drawing it very schematically because we want to understand it. So something which is over here, right? Just in the midline, we call this thing as arcuate nucleus. Then there is something which is on the medial side, and then the absolute lateral part, right? This is completely schematic because we want to understand the concept, right? So that's the, simply speaking, we just say this is arcuate nucleus, right? This one is ventromedial, and this one is lateral, right? Lateral hypothalamic area, right? These are extremely important for the hunger and the satisfaction. Now, yes, it is very much likely that right now we might understand, remember, but then later on we forget it, right? It happens. So that's the reason, say, we can't afford to forget certain things. And what's that? Say, ventromedial, theoretically, if I say, right? So it is very easy to say that, okay, ventromedial nuclei, right? It is for satiety, right? Ventromedial nuclei is for satiety. Satiety is satisfaction. When we have consumed food, we feel happy. It is other words like fullness. We are full. Stomach is full, right? Lateral hypothalamic area, right? That is like a hunger center. It is like hunger area. So when we are hungry, right, it is this center. But definitely, if not today, after few days, we are bound to mix this concept, right? Whether it is here or here. So remember it like this. Say, when you are given food, right, and if it is very good, right, it is very good, you really like it. So what would you say, right? You will say, wah, wah, right? When we are hungry, we never say wah wah, right? When we eat, when we are happy, then we say wah wah. So this ventromedial nuclei is wah wah, right? That means we are happy, stomach is full. Against that, right, when you are hungry, you will be shouting. At least we used to do that thing in hostel, right? And literally banging the plate on the table, right? Ke bhai lao lao khana lao, right? So that's why when that call, right, ke lao lao, right, get the food, khana lao, right? So that's where it is the hunger area, and it is with L, right? It is with L. So from this point onwards, we'll definitely every time we'll be revising this, that ventromedial, right? That is a Vahva center, that is for satiety, fullness, and then that hunger area, that is where we'll actually see that banging the plates, right? Okay, so here it is. Let's pull up a figure, right? And it is this. This is what we do, है ना? Right? This is what we do. right? When we are so hungry. When we are so hungry, this is what we do, right? So here it is. This is what? Stomach, right? And this stomach is empty, right? So it means the walls of the stomach, there are mechanoreceptors, right? They are called as mechano, and receptors we are writing like R, right? Mechanoreceptors. Mechanoreceptors means they are sensitive to stretch, right? And if the stomach is empty, this is how we are, right? And we keep on imagining, right? All sorts of foods, right? So in that case, right? Food, right? So in that case, there is no stretch on the stomach, right? Mechanoreceptors, there is no stretch, right? When there is no stretch, this sensation would be carried by vagus nerve, because vagus nerve has to report. Vagus nerve will report to this medulla, and in medulla there is bichara one akela nucleus, right? He is so lonely, right? That's why name is given as solitary nucleus, right? So this solitary nucleus, right, this vagus goes and tells its dard to solitary nucleus that yaar, this stomach is pura khali pada hai, there is no stretch, I don't know what to do. Solitary nucleus will say okay, don't worry, right? I'll do something. So solitary nucleus will go to arcuate nucleus, right? Arcuate nucleus is in hypothalamus. You are right. It is in hypothalamus, right? This arcuate nucleus is very enthusiastic, right? Arcuate nucleus will say that, see, we have two things with us, right? We have one Vahva center, right? And we have another center which is like lao, get the food, right? What's the situation? The situation is stomach is empty. Oh, so we need to tell this Vahva center that you just don't speak anything, right? Otherwise, unnecessary, if you'll say yes, this is very good, so then food will not be served. And this lao khana, right, stimulate it. So in other words, this arcuate nucleus will stimulate that lateral hypothalamic zone and will inhibit ventromedial nucleus. True, right? Ventromedial nucleus, that would be inhibited, and this lateral hypothalamic, so let's write it, lateral hypothalamic, that would be stimulated, and this ventromedial would be inhibited. Once we know this, so then we are super intelligent, right? Then we can say that ventromedial, which is satiety center, because then and then we'll say wow, right? So ventromedial is the satiety center, that is what is inhibited, and lateral hypothalamic, which is a hunger center, and that is stimulated by the arcuate nucleus. What's the big deal in this? Nothing, right? But it looks so stylish, right? As if we are talking about some very hi-fi thing. These are such simple things. And let's add something even more interesting to that, right? And that is, how about defining the fibers also? Now, anorexia, right? Let me remove this part, right? So that I can use this. Anorexia, right? Anorexia means you don't eat, right? Anorexia means no food. So there are fibers, right, which are orexigenic and others are anorexigenic, right? Anorexia, it came from that word. So for this ventromedial, we want to stop it. So we'll use the fiber anorexic, okay. Anorexigenic, yeah. And these are orexigenic. So in other words, orexigenic will say eat, anorexigenic will say don't eat, but we are inhibiting it. Right? So these are just the type of fibers which will be used. Okay. All right. So this is main thing, that which centers are getting affected. Everything started from, okay, so that's good. So everything started from that stomach, right? So that stomach which said that yes, these are the things. Now still this is story number one. So let's put one, right? This is not the end of the story. There is the second part of this story. And this second part is, let's say this is our hunger story, right? It is our hunger story. So decrease stretch on the stomach walls, but there is also decrease in blood glucose, right? There is decrease in blood glucose. So both of them, they will be affecting, again, it is the stomach only, because see, such good mechanisms are there. There are G cells in the stomach lining, right? These are the G cells. G cells. So these G cells, they will respond. They'll say, okay, vagus is already carrying that information, but I need to release something. So see, it is like khana na, bhook lagi hai, right? So we just can't rely on one vagus. So let's take another route, right? That route is blood. So let's inform that arcuate nucleus, because arcuate nucleus is boss, right? If we send our message to arcuate nucleus, he'll manage everything. So we said that, okay, vagus is already going, sending the message via nerves. Let's send the another message by bloodstream, right? So by bloodstream. And in bloodstream, it would release a messenger. And this messenger is hunger hormone, right? Hunger hormone. He'll say, okay, go to this arcuate nucleus and tell them that how hungry am I, right? So this is what is called as the ghrelin, right? That's why G, right? It is called as the ghrelin. Right. So this will be traveling all the way to, from the blood, it will reach to arcuate nucleus, and once arcuate nucleus is informed, you know it very well that what it will do, right? It will stimulate someone and it will inhibit someone. It will inhibit who? That V, right? So V is ventromedial nucleus, correct? And this is lateral hypothalamic. So that would be stimulated. Done. And the problem is solved. Right? Okay. So it is good now. It's clear. All right. Now what if situation is different now? Now things are good, right? And it was unlimited pizza, right? And we consumed lavishly. And now things should be something like this, right? Like this, right? And I know those who live in hostel, right? I used to live in hostel, right? I was like one of such person. Okay. So let's flatten. So now it is in our notes. Okay. Right. So when this thing happens, right? Now same stomach, right? Same stomach is telling that enough, those mechanoreceptors, right? Those mechanoreceptors, right? They are stretched. It's too much, right? Yeah, it is too much. But I think, Hafiz, have you stayed in hostel? Because if you stay in hostel, so then you feel this is not too much of food. Okay. So mechanoreceptors, when they are stretched, right, it is same that vagus nerve, right? That vagus nerve will go. It will go to whom? It will go to that solitary nucleus, right? Solitary nucleus is where? It is in medulla, right? Then from this medulla, it will go where? It will go to that big boss, arcuate nucleus. And this arcuate nucleus will say, okay, the message is now the stomach is stretched. So this is a strong message, right? That stomach is getting stretched. Okay, so he must have consumed so much. So we need to stop someone, and we need to stimulate someone, right? To whom? Domino's pizza. Okay. But Domino's, they don't give unlimited pizza, Ankit. They don't give unlimited. Or do they give? I think they don't give unlimited pizza. Because there are some schemes where unlimited pizza is given. But there to you just crash, right? Till they throw you out of the restaurant, can now stop eating. You eat till that point of time. Okay, so this is the situation. Now stomach is telling that, okay, enough of the stretch. So now arcuate nucleus will say that, okay, stop. Stop. Whom to stop? Let's stop that center, and that is lateral hypothalamic. Correct? That is to be stopped. No more lao, right? Enough, right? And then just start appreciating that, wow, it was good pizza, right? So that is ventromedial nucleus, right? So now we start appreciating, wow, right? Very good. Food was good. And that's how things go. Someone consume? Well, in that case, right? I'll just answer it in 1 minute. If you start consuming even more than what is possible, only two things can happen. One, it will throw back everything. But if someone keeps on consuming more and more and more, so that's why it is said that diet, the food which we diet, and the sleep, they can be increased, they can be decreased. Now, well, one can eat even beyond limit for certain time, but after that it is definitely harmful, right? So over here, and you'll appreciate that God has given such amazing, say, things for such controls, right? And we'll see that. So here it is, first thing, it was fine. Now the second is, say, this is our stomach, that's the duodenum, right? That's the duodenum, first, second, third, fourth part. After that, this is jejunum and all those coils, and finally there is ileum, and that ileum would open into cecum, right? And then there is colon, right? That is the ileocecal junction, and that's the appendix. Right now we just draw this much. As the food enters into the stomach, that mechanoreceptors, they have already informed, right? But this food will be entering into duodenum, jejunum, ileum, right? And it has started processing it. When it has started processing, that means it will be releasing, irrespective of what we eat. Body understands only three currencies, right? Body understands only three currency, and that is, it understands that, okay, it is the glucose, right? That is good. It will say proteins, so in that case they are like amino acids, right? And the fat, bus. It will say, let's break down these things into these and then start utilizing it. So in that case, when they are getting synthesized, right, when they are into the system, so they are now called as the chemoreceptors. So we do have the one which was the mechanoreceptor, which was into stomach, right? Now these are chemoreceptors, right? So from stomach, from intestine, right? All of them, when they find that, yes, these interesting food products, they have now been converted to glucose, amino acid, fat. So then we need to inform someone, and that someone is ENS. You know ENS, we talked about it, enteric nervous system, right? So enteric nervous system. Enteric nervous system is like a second brain, right? Second brain. So it is into GIT. So when all these things are happening, it will say it will take too much of time to go all the way to the brain and inform that, yes, we have got glucose and amino acids and fat. Let's do one thing. We have our inbuilt in-house system, And that in-house system is what is called as the entero, right? Endocrine system. Endocrine system. Enteroendocrine system. It will say we need to release certain hormones so that we only manage these things by ourselves, right? So that enteroendocrinal system, it will release the hormone, right? So hormone released. Now which hormones? Such a beautiful system is there, and in order to understand this, let's make it this way. The first thing, fats and proteins, right? Fats and proteins. We have stomach, duodenum, jejunum, ileum, right? So duodenum, jejunum, ileum, right? They are there. Out of that, fats and proteins, right? They will act on the duodenum and jejunum. And these cells are eye cells. They are called as the eye cells. Right? They'll say release CCK. CCK is cholecystokinin, right? CCK. In digestive system, we'll be discussing this thing in detail. But here is what happens. Fats and proteins, they act on eye cells of duodenum and jejunum, and they release CCK, cholecystokinin. Same way, another pair, right? This pair is about, say, over here, this fat, right? So this fat, or just write like this, right? So this looks neat. So this fat will also be acting, right, as, just a minute, let's write it on another page, right? So this is this is it. So first we say that duodenum, jejunum, they are done, and then for the ileum, right? This is for the ileum, not this ileum, right? Not this ileum. This ileum is hip bone, correct? Ileum, ischium, and pubis, hip bone part. So that is that ileum. So we are dealing with this ileum. In this ileum, there are L cells. And these L cells, they are classically affected by one, glucose, right? We already talked about protein and fats, right? So this glucose is affecting on L cells, and that will lead to one very interesting thing. It is called as the GLP-1. GLP-1. Now what's this? It is glucagon like peptide. It means these are peptide hormones, right? Number one. But it will behave like glucagon. It is not glucagon, right? It is not glucagon, right? When the glucose is gone, so at that time, this glucagon will come into picture, right? It is just the bhai of insulin, right? So this is glucose. When it is there, L cells, they lead to glucagon-like peptide 1. And on top of it, say that protein, right? Protein which was acting on eye cells, so that also releases that CCK. And this protein, which is at, just a minute, let's take this. This protein will also act on this L cells, right? And because it is protein, so it will lead to formation of this peptide hormone, and it is called as the YY, right? So how is the summary? Let's keep a simple, very easy summary. See, protein and fat, right? they act on eye cells of duodenum and jejunum. What they release? They release CCK, cholecystokinin. True. Then let's write here again. Protein will act on the L cells of ileum, and it will release what? YY, right? Which is a peptide hormone, right? So it is YY. We have already written about peptide hormone, so we'll keep it like this. And finally, the glucose, right? It will act on L cells, which is into ileum, and will lead to GLP-1. So these three. And all these three, right, collectively, what will they do? This one, this one, this one. They'll say, let's go to, yes, you must have guessed, let's go to that big boss, and he is arcuate nucleus, right? And then how is the situation? Situation is that, well, there is so much of protein, so much of fat, so much of this glucose, everything is so happy. So what should be done? Someone should be stimulated and someone should be inhibited, right? And guess what will you do? Who should be inhibited? Who should be stopped? Right? Obviously, we'll stop someone who is telling ke lao khana. So we'll write this L. That means lateral hypothalamic. That should be inhibited, and we should now start appreciating that good food, right? So say wawa, right? So this is wawa, and that is ventromedial nucleus that would be stimulated. Done, everything set, right? So over here, so this is giving me ideas to ask you so many questions about these I cells, L cells. Regarding this protein, I can ask fat, right? This protein, glucose, then also GLP, then this YY, who secretes YY, who secretes CCK, right? So many questions, right? See, I'm helping you that which questions will be asked, right? Okay. The system is so good that I think I have to block someone. I can never tolerate this sort of nonsense. Whosoever is, I'm blocking you. Not only that, I'm even reporting. This is really bad. No such words, because it's good that it has automatically been stopped, right? But I am hiding. Whosoever you are, I am hiding you, and I'm banning you from this site. It can, such dirty words can never be tolerated. Report. And this is unwanted harassment or bullying. I am reporting it. This is bad. Friends, someone started writing such a dirty language, and I have banned him, but this is really bad. This is this is really bad. Means someone spoke very bad about a respectable female, right? Must be some student from our group only, right? But anyway, it is really bad. Means how can someone write such dirty sentences? पॉसिबल जाएगी. यू आर राइट. कोई बाहर का हो, पॉसिबल है. No, I have already banned him and I deleted all his messages. Because what really happens is that they appear onto this recording, right? So it is because he wrote someone's name also, and that is disgusting. It's when we are studying something, say in case if he's not interested, he's free to go. Why? It's okay. I don't mind. Means it's okay. I mean, someone is writing such nasty. It's okay. You can give 100 dislikes, no problems. I'm telling live, no problems. You give 100 dislikes, but okay, doing from another ID. Really disturbing. Sorry, friends. Say I had to ban him, but true, Ganga. That's right. Can't do that. Okay. Chalo, let's go back where we were. So we were talking about protein, fat, right? Then these are the I cells, protein and glucose. These are the L cells, right? And all of them, they will be going to arcuate nucleus, and then arcuate nucleus will be told that there is enough food, everything is fine. So ventromedial nucleus, right? Say Wawa and stimulate him, and then lateral hypothalamic zone should be said inhibited, right? So that's how things they improve. Now there are some other functions. It is not only that they do this much, right? These are some other functions. Now remember, these other functions is what you must remember in exam when it comes like this, right? Mayuri, some means it's like he was telling bad to those females. And she is someone from you only because he wrote the name. That's why I felt so bad. Anyway, so other functions, you should always remember these extra functions because they'll be carrying the cutting edge. They'll be giving you the cutting edge. As normal functions everyone would remember, these are some classical functions. The first one for the CCK, right? Cholecystokinin. Now see, cholecystokinin, name itself is telling that it is related to gallbladder. So it will stimulate, right, gallbladder activity. That is the gallbladder contraction. It will lead to gallbladder contraction. That would be more appropriate, right? Gallbladder contraction. Plus, it will increase peristalsis. Right, it will increase peristalsis. So it makes sense, right? When the food is digested, when glucose, amino acids, everything is there, to chalo aage, right? So that's why that peristalsis would continue, right? Then see that peptide hormone, right? Peptide YY, right? That peptide YY. It will say what was ghrelin, right? Ghrelin was ghrelin, right? It was hunger hormone, right? So now we are no more hungry. Now there is so much of, say, fat and protein and fat, everything, right? We have consumed so many pizzas. So now we are not hungry. So we'll tell this ghrelin, ki acha baba, ab now shant, right? If you remember, this ghrelin was that hunger hormone, and that was released by this G cells, right? G cells. Correct, right? And then finally, it was that glycogen-like peptide 1, right? Glucagon-like peptide 1, and it will increase. This is very interesting. It will increase insulin secretion, right? And where it will in the pancreas, right? Now when that is secreted, when insulin is secreted, it has to be because there is insulin, it has to be so that, say, there is so much of energy, so insulin will tell the cells कि chalo, there is enough resources, right? Enjoy, all of you eat. So cells will start picking up the glucose. It will go to liver. He'll say, "Kya, there is so much of glucose running. So take that glucose as my fixed deposit and convert it into glycogen. Whenever it is needed, I'll tell you, and you break my fixed deposit. And from glycogen, you give me the glucose, and that's how things would go." And it will go to hypothalamus. And we'll say, okay, now start telling Vava, right? So that we don't want to eat further. That is what really happens in case of insulin. So if we write these points, right, in simple words, we just have to mention 3 points, 1, 2, and 3, right? It will tell the cells, increase uptake, right? There is so much of energy, right? Use as you like, right? Eat lavishly. So increase uptake of glucose, right? Then it will tell the liver, right, that there is so much of glucose. So this glucose you convert to that fixed deposit, right? And that is glycogen, right? So glycogen would be stored. And then go to hypothalamus, right? Hypothalamus. And what hypothalamus, right? You'll say you go and you tell your arcuate nucleus. And what should we tell to arcuate nucleus? Stimulate something, block something, right? What is to be, oh my God. Uh, I'm not, I'm not taking anyone's name, but there are some bad words getting written on the chat. Any of the females can, or can anyone confirm that can you read that or no? Someone is writing some bad words. Is it appearing? Because over here it is show or hide. Okay, I'll hide it. So I think most, no. Chalo, then that is good. It's not reaching to you. Okay, fine. Okay, okay, okay. It's not visible. Fine, fine, fine. Very nice. Okay, all right, fine. Yeah, true, Kapil. It's like someone can keep on creating as many IDs, and this is like a open thing. Doesn't matter. If it is not reaching to you guys, no problem. So then it is fine. Let him write. Okay. So arcuate nucleus will stimulate who? Will stimulate Va. Right. Now this time I am not writing ventromedial, because now when will you be revising the notes from V, you have to remember that it was ventromedial. And will inhibit what? Inhibit that lao khana. Right. So we'll stop that. So that's how these things go. Now in this, very interestingly, that CCK, then the GLP-1, right? YY, right? This YY is very interesting. So I feel like speaking it again, YY, right? And insulin, they all keep on fluctuating, right? They do fluctuate. But have you ever thought of that? See, the night when you wake up, or when you are awake, literally when there is that jagran, right? So for some reason, if we are awake till 1 o'clock, 2 o'clock, watching some movie, so then we in the middle of the movie at around 12:30, we feel like, yeah, let's check, hai kuch khana pada hai, let's eat something. And then whatever it is, whether it is biscuit, whether it is popcorn, whether it is even that roti, padi hui roti, right? We eat that. Why it never happens like when you are deep asleep, right? Till morning, you are not eating anything, but if you are awake, you feel like eating, right? It happens. No, Abrar, nothing to worry, because if it is not reaching to you guys, right, so then nothing to worry, right? Yeah, still that it's Mayur, it's abusing. He's abusing you now. Uh, yeah, because He has started writing some names also. Anyway, literally sometimes. Okay, I'll not see the chat for some time, right? Let's understand this topic. Then I have already reported. I'll report all of them, whosoever, whatever the IDs which are getting generated. It's okay. I know how to block them. Acha. So cells increase uptake, liver glucose to glycogen, and hypothalamus arcuate nucleus, right? Stimulation of that VAVA and inhibition of that. But these what we are talking about. CCK, GLP-1, YY, and insulin, they keep on fluctuating depending upon what the level is. But it never happens that when we are deep asleep and suddenly we wake up and then we feel कि चलो कुछ खाया जाए, खा के then once again we go to sleep. No, it never, normally it never happens, right? Yeah, I'll disable the chat for some time, Krishna. I think you are right, right? I'm sorry guys, but say let's finish the topic, then I'll turn the chat on. Okay? Yeah, actually they are like parasites. And the language which he is using, that is pathetic. That is pathetic. And I think you are right. He is definitely not a medico. Surely not. Because okay. So I am disabling the chat. Yeah. All right. The chat has been disabled. Okay. So let's now so we focus on our subject better. So it is the leptin, right? It is the leptin. It is a satiety hormone. It is just the ulta of that ghrelin. Ghrelin was that yes, khao. Leptin is no shant, right? So that's why it is a satiety hormone, satisfactory hormone, right? And leptin, right? So जब आप लेटे हुए होते हैं, so at that point you don't eat. So that's why this leptin, it acts when the person is sleeping, right? So that's why it acts at night. In sleep, you don't feel hungry. Say thanks to this leptin, right? Otherwise, this is an interesting thing that suddenly at 2 o'clock in the night, right? You feel hungry, you wake up, you eat, and then you go back to sleep. Well, sometimes we do that, right? Okay. Now here is one of the best mechanism. This leptin is released by whom? It is released by adipose tissue. Right? It is released by adipose tissue, that is those fat cells, right? So it means it will say that if the fat cells are more, so it will release leptin. Leptin will say, "Arey, satisfied, don't eat." It will go to arcuate also. Yeah, you handle both of those bandas from this wawa and lao khana, right? So this is like a natural control over obesity. So the moment those adipose tissues, they start increasing, immediately this thing will work. But why people get obese? Because when they even go beyond this, right, they override these nice mechanisms, and that's where things work like this. Okay, now we move on to it's time to call pituitary, right? Pituitary. And I am adding one figure, and this is, where is it? Here it is. That's right. This one is to see the histology of pituitary. Deliberately I have put this thing because in one figure it can teach you so many things. One, this is anterior, right? This is anterior pituitary, and this one is posterior. Okay. What was the another name of pituitary? It was, you remember that? Hypophysis, right? Yesterday we talked about it. Hypophysis. And anterior, A for A, right? Anterior is adeno. Adeno means it is glandular, right? It is glandular. That means it has got secretory function. It has got secretions. It can secrete because there are special cells. So then how hypothalamus will come and tell that anterior pituitary? The only method is via blood, right? So for anterior, it has to be via blood. If it is via blood, so then there has to be a special system. And that system is called as what? That system is called as the hypothalamo. That is, it will start from hypothalamus, hypophyseal, right? Hypophyseal portal system. True? Long name, but it is quite simple. So it means it is from hypothalamus to hypophysis, that is the pituitary. There are blood capillaries which will be carrying that hormone to this point. So that is there. What about the posterior one? Well, posterior, so it is already a continuation of hypothalamus, right? So that's why this posterior one is having all those axons which are coming from the top, right? These are unmyelinated. So that's why you'll find that even it is appearance is also very light, right? It is not staining. So it is light appearance. So that's why when the cross section is there, instantly you can know that this is where we are dealing with the posterior, right? And that's the anterior, right? Looks wise. So absolutely. But watch for one extra thing over here. It is this, a place which is, right? Let's see the color. This one, can you see, right? There is a very clear area between both of them, between anterior and posterior. So this is what is called as the pars intermedia, or intermedia, pars intermedia. Now it is like a blank space. It is cystic, right? It is cystic. Is cystic. So when we figure out that what exactly it is like one name which you have to remember. It is the remnant, right? It is the remnant of Rathke's pouch. Rathke's pouch. And what Rathke's pouch is? It is the embryological structure, right? It is embryological structure. And this structure is responsible for making anterior pituitary, because posterior pituitary, so it is forming just as an extension of that hypothalamus. But this anterior pituitary, that is developing from this Rathke's pouch, right? So that is the embryological structure making anterior, right? Specifically anterior pituitary. Posterior is continuation, right? So when we talk about adeno means glandular, right? If it is glandular, so that means it has to be rich in its blood supply, right? Then it can rich in blood supply. This is what we really see in the histology, right? So therefore it looks more red, because for him, that's the only communication which can really say that, okay, via blood those messages are coming, right? Messages for release of those hormones. Okay. Now when we talk about those cells, say there are two types of cells. One is liking the color, one is not liking the color. So chromophil and chromophobe. Phobia. So this is those who are not liking the color, they will stain weak, right? They'll stain weak. They will look light because they have not been picking up that stain. And those who are chromophilic, they fill the colors, right? They fill the colors. So we'll write they fill the colors. So when they fill the colors, they look bright, right? So whenever we deal with any of the cell, if it looks bright, that means it is chromophilic. It means it is picking the stain strongly, right? Stain, whatever the stain it is, right? Okay, now these chromophils, right? Chromophils. This one page is, again, I'm putting a star. I'll definitely ask one question from this page, right? These chromophils, there are two types. One is acidophilic and another one is basophilic, right? And you should have heard these names as acidophilic and basophilic. So B is for blue, right? So B is for blue. They basophilic, they appear blue, right? And these acidophilic, they are red, right? So this is purple or blue, but I always remember it like blue. So then purple is like blue only, right? Though someone would laugh that purple and blue, they are different. Especially the girls would say, no, these colors are different. But for males, purple and blue, they all are same, right? And every male would agree, yes, yes. Okay. Because in females dress, right, I at times wonder, means even how effectively they can pick up कि नहीं, this shade is lighter than that, and how all those girls, you remember all those various shades, and then how do you really match those colors, right? That is still a mystery, right? None of the males, they can really say decipher that thing, that how they can say. And actually I have heard that, right, that when it comes to say red color, so then there can be 20 shades of red color, but for males red is red, right? There is only one shade. So over here, acidophilic and basophilic. In acidophilic, these are the cells, they are called as the somatotrophs. All the cells will be called as the trophs, right? As if they are trophies, right? So they'll be trophs, right? So it saved us from writing so much. So somato, right? Lacto. So somatotrophs. So we'll just write capital T here, right? So that it is conveyed. So somatotrophs, lactotrophs, somatotrophs, they will release GH, growth hormone. Why growth hormone and somatotroph? Because another name of growth hormone is somatotropin, right? Somatotropin. Good. And lacto, so that is the prolactin, right? So lacto is lactin, so this is prolactin. So these are like lactotrophs. These are the cells which will be releasing prolactin. They are acidophilic. Somatotrophs, they are releasing GH or the somatotropin. We'll change the color over here, right? Let's take blue, right? So this is corticotrophs, and you have guessed it correctly. It will release what? ACTH. Correct? Corticotroph, because there cannot be another name like that. So this is gonadotrophs, and they will be releasing follicle stimulating hormone and luteinizing hormone. True. And finally the thyrotrophs. So they will be releasing thyroxine releasing hormone. Done. So these are all the, on one page, acidophilic, basophilic, everything has come up, right? These are the cells. Say, just to remember, right? This is F A-T. So if we remember it like fat, right? And say world's largest creature is what? It is blue whale, right? Blue whale. So obviously everyone would be telling that blue whale is fat, right? Relatively fat. So that means these basophilic cells, right? They are like follicle stimulating hormone and luteinizing hormone. This is A, so that is for ACTH, and this is T, that is for thyroxine, the TSH, that is thyroid stimulating hormone, right? So that's how we remember this, right? Highlighted. Okay. I just pull up one more figure, right? That is the figure which is important for our understanding. This one. Now this figure, just it and let me freeze this thing. Okay, now it is part of our notes. See, in this, this is herring body, right? You remember that herring body? What was herring body? This is part of posterior pituitary. That's what we are watching. Posterior pituitary, there are axons, and these axons, in that there are dilated nerve terminals, right? And why they should be dilated nerve terminals? Dilated nerve terminals because hypothalamus said, see, I am producing some hormones, right? So they are like what? Oxytocin and antidiuretic hormone. Let's say I'm producing this oxytocin and ADH. All you need to do is store them, right? So he'll say, where should I store? He'll say, okay, you have got the axons, so they're dilated nerve terminals, store it over there. So it's okay. He'll say, okay, these are the store terminals. And they are called as the herring body. They are called as the herring body. Right? Then you can watch some other cells also over here. Right? See here, here. They are quite small. Right? These are glial cells. Right? You remember what was glial cells? Glial cells are non-neural supporting cells. True? So non-neural supporting cells. And because it is pituitary, so that's why they are called as the pituitocytes, right? P-I-T-U-I, pituitocytes, right? Pituitocytes, pituitary cells, so pituitocytes. So that's what they are. These are pituitocytes, and those are the herring bodies, right? And in herring bodies, they are the dilated nerve terminals where these hormones released by hypothalamus, they are stored over there, and then on command they are released into the system, right? So that's how it goes. So now we have come to that point when we were dealing with, like, say, in pituitary, right? Say there is ACTH and the growth hormone, right? This is for the anterior part, that is the adeno part, A for A, adeno part, so that's why it is adenosis. And then we have got the ADH, antidiuretic hormone, and the oxytocin, right? That's what we'll be dealing for the posterior pituitary. Right? So let's start with now ACTH, right? What it really does. Now, Adrenocorticotrophic hormone, ACTH, yes, we know that it will be going all the way and it will be affecting the adrenal cortex, right? Right? Adrenal gland. cortex and medulla both, adrenal gland, right? So adrenal gland itself would be a big topic. One full session will be for that, right? So we'll be covering our path all the way from hypothalamus to pituitary till it reaches the adrenal gland. What really happens, right? So that way, and similarly we'll go for the growth hormone. Now growth hormone is important, right? Because it will be acting over here, so that's why that would be taken in slightly more detail. So here adrenocorticotrophic hormone, right? Adrenocorticotrophic hormone, or it is also called as corticotropin. It's one and the same thing, right? Corticotropin is also the same thing. Now these are all peptide hormones, right? These are all peptide hormones, and they regulate this adrenal gland, right? Adrenal gland is also called as the suprarenal gland, right? Suprarenal gland. And in suprarenal gland, both the, that is on the, they sit on the kidneys, that is renal, right? On the kidneys. One important thing which we need to know is that out of these two, this is the right, this is the left, right? Who is more romantic? Well, right, chat is off, so I'll give the answer. It is the left which is more romantic, right? Because the shape of face is what? Is like crescent. It is like a crescent. Crescent is what? Crescent is like half moon, right? So, and what about this right side? Well, right side is interested in visiting all these places. So this is like he's like an explorer, and that's why this gland is pyramidal, right? So much inspired by the Egyptians. So this is pyramid shaped. Okay. So that's how these they look like. So entire process would be like this now. Hypothalamus, right? And then via hypothalamo hypophyseal portal system, right? You got the point? Portal system, which is nothing but blood capillaries. So that way it will reach to posterior pituitary. Am I right? Is it posterior? Anterior, right? A for A. So remember this. At many places now we'll start following it, this principle. Say deliberately we'll write and we'll cut. So when you'll be revising it, this thing will be imprinted. You'll be remembering this entire thing as a picture, right? So that way you'll always remember that it has to be like this. Okay. Now ACTH was was released by what type of cells? It was by those chromophils. But in those chromophils, it was acidic or basic, right? Well, we said that blue whale, right? That was fat, and this was the ACTH. So it is basophilic, right? So basophilic, it will be staining what? Blue, and yes, we remembered that, right? Purple. Blue or purple, that means they will be staining blue or purple, right? So ACTH is by basophilic chromophils, and they'll be released like this, correct? Okay, the next is that this ACTH on command of, right, it is released by what? It is released by, because hypothalamus will be sending something, and this is corticotropin releasing hormone, right? So by this bloodstream, in fact, it is the CRH will come. CRH is corticotropin releasing hormone. So this will come to this anterior pituitary, right? Now why anterior pituitary should really release it? So this is the cell. On that there is a receptor. So this CRH will come and will connect to that receptor. Now in that, inside the cell, there are some large precursor molecule, right? Precursor means it is in raw form. So they are called as the large precursor, right? Precursor molecule. It means that if these molecules they are lying over there, they won't be doing anything. But then when it comes in contact with this cortico releasing hormone, these molecules they break, and in the process they release ACTH in blood. It is worth remembering or even worth knowing name of this large precursor molecule. It is already said that it is a large precursor molecule, so its name is also large, right? But it is very interesting. It is like a music, right? Pro, right? Though it is a these are the, but then we'll be breaking it. Pro, opio. It is POMC, right? So then it would be Milano. Pro, opio, Milano, POMC. C is cortin. That is easy, right? So pro, opio, Melanocortin. So this is actually called as POMC. Right? Maybe they both must have combined it. So it is pro, opio, Melanocortin. Right, that is POMC. It is nothing but it is a large precursor molecule, so that ACTH is released because of that. It simply breaks this POMC. It keeps on breaking, and then finally, out of several other products, one of the product is ACTH. Now this ACTH, it is released for the entire day. It keeps on releasing, right, in more or less proportion. So this ACTH is released for the entire day, right, round the clock. Maybe sometimes it increases, decreases, but when there is hypoglycemia, definitely, because it is like an emergency. When there is infection, definitely, right? That is where ACTH would be released. Why in infection? Because in infection there are cytokines, right? Because whenever there is infection, that our fighters, right, they come to picture, and those cytokines, they will go to hypothalamus. They will stimulate them. They will tell the hypothalamus that we are fighting, right? So it will say, okay, I'm telling my pituitary, right? Which pituitary? It will say that anterior is for different purpose, posterior is for different purpose. This is what? This is ACTH, adeno, so it has to be anterior. So it is anterior pituitary releasing ACTH, and then it goes to adrenal gland. And when we'll see adrenal gland, it has got so many functions against this entire process, right? So that's how everyone goes and informs hypothalamus that we are in need, and it releases accordingly. Now this ACTH, right, what it will do? Here is the adrenal gland, right? This is the adrenal gland. And on that adrenal gland, right, there is receptor, right? There is a receptor. Now this receptor is not a seedha sada receptor, right? This receptor is 1, 2, 3, 4, 5, 6, 7, right? This is what is called as the 7-pass transmembrane receptors. Now these are also called as the integrated receptors, because it's like if you try to take out these receptors, then you'll destroy the entire cell wall, right? Entire cell wall would be destroyed. So they are like integrated receptors. And what they do, that when there is a specific stimulus over here, they do something inside. Right? That's what the receptor is. So here, this ACTH, now say this is adrenal gland, right? So ACTH, it comes over here. And these are ACTH receptors. So when these ACTH receptors, they come, they lead to what's called as, say, these receptors, they are very specific. These are on adrenal gland. So we do have a separate name for this receptor, right? Till this point, we were calling it as ACTH receptor, right? That is okay to remember. We say that it is a 7-pass transmembrane type of receptor. Fine, that is the type of receptor. But the name of this receptor is melano, right? We just had that word above, right? So melanocortin, but receptor number type 2. So that means there must be one melanocortin type 1. Yes, it is there, right? We are about to talk about it also. But do remember, this melanocortin receptor type 2 is for adrenal glands because there are 2 adrenal glands. So that's how we remember, right? So melanocortin receptor 2 is for glands, right? Right. So there are 2. So we don't forget. Let's unsolve the mystery that melanocortin receptor type 1, right? Type 1 is for skin, right? Because there is only one skin. So that's why type 1 is for skin. We'll talk about it in more detail just in a while. Okay. So now this adrenal gland, rest of the story from here, it is easy. It is the outer cortex. So we'll go a bit fast. Outer cortex, and then there is inner medulla, right? Inner medulla. And this inner medulla, it is releasing what? It is releasing all that sympathetic system. It is handling that ANS, and it will release that epinephrine, right? And norepinephrine, and that is collectively all are called as the catecholamines, correct? Catecholamines, done. Now it is the outer cortex. Outer cortex is bigger one. If it is bigger, so we remember it like G, F, R, right? They all are zona, right? So zona glomerularis, zona fasciculata, and zona reticularis. So in case of glomerulosa, right, it will be releasing mineralocorticoids, right? Mineralocorticoids. So it will be handling that. And corticoids, C, corticoids. Example, aldosterone. So there would be so many diseases associated with all these endocrine system, right? So simply, if anything is decreased or increased, yes, it will lead to so many complications. That's what really happens. Similarly, zona fasciculata, right? Fasciculata. So this is most important. It is glucocorticoids, right? Glucocorticoids. And that is where example cortisol, right? Stress hormone, right? Cortisol, then corticosterone, cortisone, so many are there. And finally, this is reticularis. Zona reticularis, that is for androgens, right? It is for androgens. Androgens, they are classically to stimulate muscularization, right? So muscularity is with these androgens. Now there is an example. This is what is called as the DEA, right? Just before some time, I read this article. There was one article, and this DEA is dehydroepiandrosterone, right? So it is dehydroepiandrosterone. And it was some medicine, and some gym wala was claiming that it leads to increase in DEA, and that will lead to increased muscularity. Right? This is completely nonsense. Right? Some things, they cannot be injected or consumed like this, because when such substances, when they go via the route of, say, oral, right, by the time when they come in the contact with say stomach acid, gastric acid, all these things, they don't carry any value. And it is clearly mentioned in those that it has not been approved by Food and Drug Administration. So that's why so many medicines, so many drugs which are say sold, and its market is in millions, nahi, it is in billions of dollars, right? And so much of consumption is going on, but actually they are not doing anything good. But it's like, say, they just pick up only certain lines from the medical books. They create the entire leaflet, or their that pamphlet, right? Their catalog, their brochure, and such things are that. And yes, obviously in books, so it would always be written that zona glandulata, it is like androgens for increased muscularity, and this DEA, dehydroepiandrosterone, is this powerful, it has got this type of peptide, etc. Yes, it is all medical fact, but technically it is incorrect. That's how they misguide so many people. Okay. Some interesting questions were asked in the mail. One was like, say, urine, right? It is why it is say dark, right? If the urine is dark, so that is the indication of dehydration. But by any means, if the urine is red in color, right, so then never ignore, because it is what is called as the hematuria, right? It is a pathology. So either it is some infection, or it is, say, renal stones, especially the oxalate stones, right? Renal stones like oxalate stones. So oxalate stones, if you see, they are like spikes, spicules, right? This is the stone, and then like this, right? And obviously the inside lining, those, it is so sensitive, so it can be damaged so easily. So these stones, when they roll, they actually do the injury, and that's the reason when there is red urine, right? It is the hematuria. Okay, now we were talking about that melanocortin receptor 1, right? There was one. So it is melanocortin receptor 1. So this is present on the skin. Now here it is very interesting. This is also a 7-pass receptor, right? So looks wise 7-pass receptor, transmembrane 7-pass receptor. So ACTH will come over here also, right? And it will act on this melanocortin receptor 1. Now what it will do? It converts one melanin to another melanin. It is called as the pheo, right? Pheomelanin to eumelanin, to eumelanin. So what this pheo and u is? Pheo is red, right? And u is black. That's the reason that many times you must have noticed that when the person is under stress, right? So there are dark circles, skin becomes dark, right? Skin pigmentation increases, those dot dot dot, right? This is what is called as the skin pigmentation, right? Skin pigmentation. So this is how everything is interconnected, right? It is because of this melanocortin receptor 1, which is present on skin, right? So that's how we now, so this is like for pituitary, we were talking about ACTH, right? So one down, one to go, right? So this is done. Now we talk about the final topic of today, that is the growth hormone, because that ADH, antidiuretic hormone, and oxytocin, right, will take, because they are also awesome topics. So that is what we'll take tomorrow, right? That is by that posterior pituitary, right? That will take tomorrow. Let's move on to the growth hormone, right? These are all anterior ones. Okay. Let me turn the chat on. Now things should be better. You must have left. Okay. Now you are back. because I like it when you write something, right? Otherwise, I feel like that I'm teaching akela akela. Okay, so this is the growth hormone, right? Growth hormone is also called as the somatostatin. Thank you, right? It is also called as the somatostatin, right? This growth name itself tells growth, right? So it is handling the rate of growth. So it means that for some reason, if this growth hormone is getting secreted uncontrollably, so then it leads to gigantism, right? They become big, right? Big bones, huge structures, right? But well, it comes at a cost, right? There are so many other complications. So that's why this endocrine system, when we'll be learning the pathology. So today only I was making the plan that for pathology, what should we learn? So then it stuck my mind that yes, in pathology, we'll be going for pathology of endocrine, right? Because that is something which is so tricky and so many name will come, and then you have to remember so many conditions. So you have to remember so many characteristics, but we'll see all those things with lots of pictures, right? So pictures of the patients. So that way you'll never forget, right? So this is rate of growth in the body, right? Of the body. So at what pace things should go. So why this growth hormone is so nice, why it is so special? What really happens is that here is the hypothalamus, right? Hypothalamus will be calling whom? Will be calling that anterior pituitary, right? Why? It will be going by that portal system. So I'll just write portal, right? Now you know what is portal, right? That is those blood vessels which are getting connected. So it will release GHRH, right? Growth hormone releasing hormone. So with response to that GHRH, this anterior pituitary will release growth hormone, correct? So this is actually the mechanism. Are Sandeep, why can't? Why can't? You can definitely attend any of the lecture, not only pathology. I would wish to see you even in medicine, surgery, gynec, everything, right? For these 10 weeks, right? Those who are not aware, I'm just telling for these 10 weeks, yes, every week we'll be going for a new subject, right? Every week. So we'll try to cover those topics which are either bit tricky, at times difficult to understand, and we'll keep on integrating in such a way that, say, as I was telling, that in pathology, yes, we'll be learning about endocrine pathology, right? So that it would be crystal clear by the end. So by the end of 10 weeks, you'll be very happy with yourself, and do appear for all the exams, though I'll be very harsh and I'll be putting 100 questions, right, in third or fourth exam, but you'll like it, right? Okay, so coming back to this hypothalamus, it is growth hormone releasing hormone, and it would be sending message to anterior pituitary. Anterior pituitary will obey it and immediately release growth hormone. And this growth hormone is by whom? Is by somatotrophs. Somatotroph. These are the cells. Somatotrophs. Right. So again, these somatotrophs, they will be having that receptor, right? That receptor, and this GHRH will act on that receptor, and then these somatotrophs, they will release growth hormone, right? Every time it happens like this only. So they go on the surface and then they say, okay, GHRH, I'm GHRH, you release growth hormone, and that would be released, right? So where was it? Just a sort of that revision that we were telling about chromophils, right? In chromophils, there was acidic and there was basophilic, right? Acidophilic and the basophilic. This is red, this is purple or blue, correct? In this, there were three. Which three? We'll write it like FAT. That is follicle stimulating hormone, luteinizing hormone. It means they are called as what? Gonadotrophins, right? Gonadotrophs. Then this is ACTH, so that is so easy, cortico. And this was thyrotrophs, right? So over here, that means we are dealing with this side, and that is where it is the somatotrophs, right? That is what releases growth hormone, and over here it was lactotrophs, and that was releasing prolactin. Correct? Yes, all those acromegaly, etc., everything will come into the pathology, definitely. Next week I'm planning for biochemistry. Okay. So GHRH, right? Which are the factors which are releasing it? So this would also be a very important point. Factors releasing GHRH. One first factor, it is 24/7 it is getting released. 24/7, right? In a pulsating way, right? So like this, increase, decrease, increase, decrease, but constantly it is getting released, pulsating way, right? 24/7. But when it is maximum 1 hour after sleep. And so much research has been done on this. 1 hour after sleep. So if the sleep is disturbed, it actually affects GHRH, right? Second is in case of obviously hypoglycemia, because growth hormone is known for that entire process. Similarly, say in exercise leads to, say, because it is like for adrenal gland, right? It is giving like that adrenal pump, right? Because when you exercise, you do it with josh, right? And when you do it, this adrenaline pump, right, it is affecting that hypothalamus. So that's how it goes. And obviously, as the person matures, that is about the puberty, that is where the spike is there. So that leads to that increased estrogen and increased testosterone, right? So that leads to all those male or female characteristic depending upon the hormone, right? So this is where it will play a major role, right? In case of any disruption into this hormonal pattern, yes, at times you will find that certain males, their characteristic are more towards female, or certain females, they are having characteristic more towards male, right? That is the reason. Okay, then next there is something what is called as the negative feedback, right? Negative feedback. Negative feedback means if this growth hormone, it keeps on stimulating, right? So then it will lead to disruption. It will lead to so many problems. So one, negative feedback means how it can really be stopped. So any increase in growth hormone, it will automatically send a message to hypothalamus that okay, decrease it. So that's the reason it is pulsating, right? Second, growth hormone will affect liver, muscle, bone, right? It will affect, and we'll see it in more detail that what exactly they do. What they do is they lead to secretion of, it is called as the somatomedins. Somatomedins. I'm writing medins, I'm writing in capital, somatomedins, right? And they will inhibit growth hormone by acting on anterior pituitary. So this is to keep the growth hormone in balance. So as soon as growth hormone is released, right, it starts its function, but liver, muscle, bone, they will also release somatomedins, and they will go to anterior pituitary, and they'll decrease it. Once it is decreased, then once again that say level drops and somatomedins level drop, and then once again anterior pituitary will release. So it keeps on moving in a controlled, definite window, right? The third, and this is worth remembering, increased growth hormone, right? One, plus somatomedins. So somatomedins we just talked about, right? From bone, somatomedins from liver, muscle and bone, they act on hypothalamus also, right? See how smart, right? They say that one, you act on the local and also act on the headquarter. So they go to hypothalamus and they will say that you release something. So he'll say, what should I? He'll say, okay, see where you have got growth hormone, releasing hormone, but you have one more growth hormone, inhibitory hormone. For the first time, this gentleman has entered into our discussion. This is growth hormone, inhibitory hormone. Inhibitory hormone, right? Hormone. And this thing is somatostatin, right? So in such case, when this thing occurs, it keeps entire system in balance, right? Now this growth hormone inhibiting hormone, there is one more interesting. It is not only from hypothalamus, but we do have a second brain also with us, right? And you know this second brain is what? It is our ENS. That means it is in our GIT. So from GIT, there are in pancreas and there are delta cells, right? Delta cells. These delta cells, they also release this GHIH, right? And what it does, this GHIH, it inhibits insulin, and you are right, it inhibits glucagon. Both of them, right? And as very truly one very scientific question which was asked, because insulin and glucagon, they are counter of each other. So what's the point in stopping both of them? This is like a reset mechanism. It is like a reset mechanism, right? So, well, God cannot say that let's reboot this entire person, right? So these mechanisms, they are rebooted. So exactly the same when insulin, glucagon, in case of because of this GHIH, it again resets to that normal level. So this is very important for homeostasis. Homeostasis means you know that it is for the balance, right? Okay. Finally, it is our GH, and this point, as I'll explain you, you'll start recollecting everything whatsoever we have learnt in last 7, 8, 9 days, right? These are the action of growth hormone, right? Where it acts. Two things. One is direct, right? They will act direct, and second is indirect, right? Direct and indirect. Direct, it stimulates cellular metabolism, right? So when cellular metabolism, it means cells will divide and it will lead to tissue growth. Well, this is logical. Okay. The second point, it leads to lipolysis. Lysis means to break. Lipolysis. Lipolysis. So it breaks, right? It breaks what? It breaks fat, right? So breakdown of fat. Why fat should be broken? Well, then and then we get the energy, right? So it is for energy. Okay. So that is the growth hormone, right? The third thing, it will go to liver, right? Growth is needed, right? We need to work. So it will say, okay, even if you don't have anything, just give us the glucose, right? So it will say, I don't have right now carbohydrate. So it will say, no problem, do it from non-carbohydrate. So if it is from non-carbohydrate, so that's why it is a new type of system. So that's why gluconeogenesis, right? It is for non-CHO resources, non-carbohydrate resources, right? Yeah, frequent revision is necessary, yes. And that's why I said that you just try to do, all of you, just try to do this just before you go to sleep, and as soon as you wake up, you revise and see the difference, right? You'll be really happy with yourself. The next is that, remember, glycogenolysis, right? It is that breaking our FD, right? Fixed deposit glycogenolysis. So we said that now we need glucose. So then this glycogen, it would be broken into the glucose and it can be utilized. This point that it also leads to what we are talking about. We are talking about growth hormone. This growth hormone, this fourth point is worth remembering. It increases insulin resistance. What is insulin resistance? Insulin resistance means that though, what's the function of insulin? That there is large amount of glucose running in the blood, right? Capture them and throw them into the liver, right? That those glucose, they should not move here and there. Now, even if the insulin is there, still glucose is enjoying into the bloodstream. That is increased insulin resistance. That means insulin effect is decreased. And why we really want to do this? It is because we say that our cells, they are demanding more glucose. So as soon as there is more glucose, so obviously insulin will come up and will capture all of them and put into liver. So that's the reason growth hormone would say, no, let's decrease its effect, right? So therefore there would be more glucose into the blood, right? True, more glucose in blood, right? Understand this process, right? In case of any doubt, just let me know, I'll repeat it, but do understand. So insulin effect is decreased, more glucose is in blood, that more glucose will reach to, it is good that tissues will use it, right? Tissues use it. But then what will happen at the pancreas, right? Pancreas will say, are so much of blood glucose, release insulin, release more insulin, right? This is actually what is happening in case of diabetic patient, right? Because in diabetes, as there is fat accumulation, as the lifestyle goes down, everything is slowing down. So finally it also develops what's called as the insulin resistance. So that's why it is called as the diabetogenic effect. So just after exercise, right? After exercise, you try to check your blood sugar. It will be spikingly high because it is like a need, right? It is like a need. A large amount of glucose is needed. After that, it subsides, right? So this is diabetic geno effect of growth hormone. And what about the indirect method? So how it is affecting indirectly? So this is indirect effect of growth hormone. The indirect effect of growth hormone is, one, as we said, that liver, skeletal muscle, right, bone, they secrete what? They secrete somatomedin. Somatomedin. Now in this somatomedin, there is one which is of very special class, right? Deliberately I said special class because it is somatomedin C, right? Somatomedin C, right? So that's why we remember it. It is of a different class. As such, it is type, but it is a different class. What it is? Its name is insulin-like growth factor 1, right? See, remember, it is not insulin, but it is insulin-like, right? It is a growth factor, but it would behave like insulin, right? Insulin-like growth factor 1. So we'll write it like, in short, IIGF1, and it is this insulin like growth factor 1 and the insulin, right? So there are few receptors which are IGF-1 receptors, which are meant for IGF-1. So they will be acting, but this is insulin-like, right? Okay, I'll come to that. So this IGF-1, right? IGF-1, it is a chemical. There are receptors for it, but because it is like cousin of insulin, so it can act on even insulin receptors. Insulin receptors, right? So in such case, everything what insulin is doing, that is done by IGF-1. Right? So it will lead to everything like increased cellular metabolism, right? Cellular metabolism, cell division, it will increase cell division, right? It will increase that differentiation, right? Types of cell formation, different types of cell formation. All those things would start because it is behaving as if it is insulin. But when it will come to, it will act on muscles, right? So it will say that it will just tell increase amino acid uptake. So it will say start eating more, right? That's what it will train. So that is good for the muscle and this leads to muscle growth. When it comes to bone, right? In bones, we know it very well that who was responsible for the growth, and well, that was the epiphyseal plate, right? There was diaphysis, end of the diaphysis, right? Then there was the metaphysis, and then there was that epiphyseal plate, right? So it is epiphyseal plate, which is nothing but a growing end, and exactly at that point, growing end, and exactly it acts on epiphyseal plate. And what it will do on that epiphyseal plate? On that epiphyseal plate, it will stimulate someone. Now we know that whom to stimulate, because there are osteocytes which are for maintenance, osteoblasts which are for formation, and osteoclasts which are to cut off, right? So obviously it will stimulate osteoblastic activity, right? It will stimulate osteoblast or osteoblastic activity. So this is the reason that why they will be boosting growth in it, right? So that's what leads to say boost of growth, right? So that was for today, right? So tomorrow what we'll start with is, say in pituitary, we'll be starting with the posterior pituitary, right? So we'll be dealing with ADH, very interesting, adding this antidiuretic hormone, and the oxytocin, right? That's what we'll be dealing tomorrow, and then we'll obviously proceed further, right? So this is the point from where we'll start tomorrow. So thank you so much. And we meet tomorrow, same time. In case of diabetes, why insulin secretion is decreased? Well, so many reasons. Minu, do one thing. Send a mail, right? I'll explain it in more detail. Vasopressin and oxytocin, yes. They will also come. Vasopressin is same, ADH. That's right. That we'll discuss tomorrow. Okay. So bye-bye and good night. See you tomorrow. And this file would be placed in our folder just in a minute. All right. Thank you.